Hello friends, welcome to my channel. In this video I will cover Vizag Steel Management Training 2015 paper. Technical parts I will cover. Paper solution part 10. Bearing characteristic number in a hydrodynamic bearing depends upon bearing characteristics number. Sommerfeld number is Zn by P d by C square. This Zn by P is bearing characteristic number. Characteristic number. Here Z is viscosity. Viscosity is Z. Speed is N and bearing pressure is P. So bearing characteristics number depend on viscosity, speed and bearing pressure. A is the answer. The state of stress at a point is given as sigma x is equal to 100 Newton per meter mm square, sigma y is 40 Newton per mm square and tau xy is 40 Newton per mm square. Yield strength also given. Sy is 300 MPa or Newton per mm square. Using maximum shear stress theory, you have to calculate the factor of safety. So, tau induced should be less than tau yield, or tau yield is Sy by 2. Here factor of safety they are so divided by 2 into factor of safety. First we have to calculate maximum induced shear stress. So I will use here more stress. For more stress, data given are sigma x is 100 Newton per mm square, sigma y 40 Newton per mm square, tau xy is 40 Newton per mm square. So first sigma x 100, then sigma y 40, midpoint we have to take 70. This distance 70 minus 40 is 30. Then tau xy, it's 40 Newton per mm square. So this is the radius from here to center. This is 30 and here 40. So radius we have to calculate. R is 30 square plus 40 square root over. You will get 50. 50 is the radius. Draw the Morse circle. You will get maximum pinch stress. Sigma 1 here. 70 plus 50 it's 120. Minimum pinch stress sigma 2. It's 70 minus 50, 20. So shear stress maximum, absolute maximum shear stress you have to calculate. Radius of 3 more circles. Sigma 1 by 2, 60. Then for this circle, you will get radius sigma 1 minus sigma 2 by 2, 50. Then sigma 2 by 2, it's 10. maximum value is 60. So you put that value 60 equal to less than equal to 300 by 2 into factor of safety. Factor of safety should be less than 300 by 2, 60. Then see 10 here 2. 10 by 4. 10 by 4 you will get 5 by 2, 2.5. Answer is B, 2.5. A shaft can safely transmit 90 kW while rotating at a given speed. The diameter of the shaft is doubled and speed is, here something is missing. Speed is the power that can be transmitted by the new shaft. Formula I am giving, P equal to 2 pi n T by 60. Power is proportional to n and power is proportional to torque T. T is pi by 16 tau s dq. So T is proportional to dq. So P is proportional to n, P is proportional to dq. So P1 by n1 d1 q equal to P2 n2 by d2 q. We have to calculate P2. P2 is P1 n2 d2 by d1 whole q n2 by n1. Put the values. This is 90 into d2 is doubled, so 2q, it's 8 into, here something is missing, so n2 by n1, you will get 720. But official answer is A. If this value is 1 by 2, then you will get that answer. A shaft is subjected to the combined bending load M and tension load T. The maximum shear stress at the outer surface, maximum tension load T, at the outer surface of the shaft will be equal to how much? So this should be torsional load. Spelling mistake is there. Torsional load, it should be there. This type of question they are asking in GATE. A problem also based on this type of formula they are asking. IS, ISRO also they are asking. So this is very, very important. Maximum shear stress we have to calculate. Sometimes they may ask maximum normal stress or principal stress value you calculate. So both here you have to know. Sigma B is sigma x. Its value is bending stress sigma B 32 m by pi dq. Tau xy 16 T. T is torsional load by pi dq. Then for principal stress, sigma 1 is sigma x minus sigma y by 2 plus or minus 6. This is plus sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square tau xy, this is plus whole square root over. So sigma y is 0, 32 m by pi dq into 1 by 2 plus or minus 32 m by 2 into pi dq whole square plus 16t by pi dq whole square. If you solve this one, you will get sigma 1 2 is 16 m by pi dq plus or minus 16 m by pi dq whole square plus 16t by pi dq whole square root over. Take common 16 by pi dq, you will get m plus or minus m square plus t square root over. This is for principal stress, but in this question they ask maximum shear stress. For maximum shear stress, tau max, its value is sigma x minus sigma y by 2 whole square plus tau xy whole square root over. If you solve this one, 16 by pi dq whole into m square plus t square root over, you will get. So from option we have to check 16 by pi dq m square plus t square. C is our answer. In a single plate cause, mu, F and Rho and Ri are the coefficient of friction, axial force, outer radius and inner radius respectively. The frictional torque using uniform wire theory, UWT. Uniform wire theory, frictional torque you have to calculate. Frictional torque formula is mu W R effective. For uniform wire theory, R effective is inner radius plus outer radius divided by 2. And for uniform pressure theory, this is also important. You remember both two. It's 2 by 3 ROQ minus RIQ divided by RO square minus RI square. Both are important. So in this question they already mentioned uniform wire theory. So 1 by 2 mu W RI plus RO you will get. So from option A is our answer. But official answer they gave C. But answer is A. If T1, zeta and P are the thickness, permissible shear stress and applied load are respectively on a cotter, then the mean width of the collar is equal to, its answer is A. Mean width of collar you have to calculate. Formula is this one. The machine element is subjected to the normal stress of 80 MPa and shear stress of 60 MPa. The yield strength of material is 320 megapascal. The factor of safety using maximum shear stress theory will be how much? Same this type of question I already solved. So here I am not solving. Here official answer is A. But I am getting this one, C. You try this question, whether you are getting or not. Same formula previously I solved. You can use more circle, or otherwise directly formula you can use. You solve and write in comment box which answer you are getting. You write in comment box whether you are getting A or you are getting C. Official answer is A. In order to cut 30T gear, we use number 4 cotter, which is suitable for the range of 2T to 34T. If helical teeth with helix angle alpha are to be cut, the size of cotter is given by. Here answer is D. Number of teeth divided by cos alpha cube. If n is the number of strokes per minute, L is stroke length in mm, C is cutting ratio. Cutting ratio is cutting time divided by total time. The cutting speed of shaper in meter per minute is given by how much? Cutting speed Vc, we have to calculate NL into 1 plus small n divided by 1000. But in this case, n is return time divided by cutting time or forward time. But in this question, cutting ratio C is cutting time or forward time divided by total time TR plus TF. If you solve this one, you will get NLC by 1000. No. You will get NL. C will come here. Here, if you use two relation, you will get 1 plus n equal to 1 by c. So you replace this one by 1 by c, you will get this. Bc is NL by 1000 c. So A is the answer. Cutting tool designation also very important for all examination. First term is back rake angle, it's 0 degree. Then side rake, it's 10 degree. Then end clearance 6 degree. Side clearance also 6 degree. Then end cutting edge angle 8 degree. Side cutting edge angle 75 degree. Nose radius in mm, it's 1 mm. In this question they asked side cutting edge angle. Sixth term. So D is the answer. Like this, anyone also they can ask. If you know the sequence, you can solve the question. First back rake angle, then side rake angle, then end clearance, then side clearance angle, then end cutting edge angle, side cutting edge angle, last nose radius. Sometimes they are asking how many terms are there. So total 7 terms, 6 angle and 1 nose radius, total 7. The basic tool in work study. Basic tool for work study. A is process chart, B is planning chart, C is bar chart, D is stopwatch. Answer is stopwatch. Stopwatch is the basic tool for work study. A process layout is generally suggested for A. Jobbing work, B. Batch production, C. Plant production, discontinuous production. This one already discussed so many times in my objective mechanical videos and ISRO also. You can check it. Process layout and product layout. Process layout is suitable for batch production and product layout is suitable for mass production. Both are I already discussed, so you can check them. Thank you friends. Thank you for watching my video. Thank you.